Hey guys, here we are for Chapter 13, Water Resources. Learn all about water as we go, and as the case with every chapter, we kick it off with a case study. We're going to look at the Colorado River. I'll throw a graphic up here that kind of shows where it flows from or to, but out in the west comes part of Wyoming into Utah, Colorado, Arizona, all the way back in. So a lot of our western states rely on the Colorado River. It flows 2,300 kilometers through 7 states. It includes 14 dams and reservoirs. And primarily the water is supplied from the snowmelt from the Rocky Mountains. Snows, etc. There's rain as well, but primarily from this melt. Comes down, flows down all the way through the states, down into the sea, usually. It supplies water and electricity for upwards to 40 million people. This is going to include Las Vegas, Phoenix, Los Angeles, San Diego, just to name a few. And it is responsible for irrigating the crops that really help feed America out in that whole area. It is a huge watershed supplying 40 million people water. Has issues with it, obviously. Very little water actually reaches the Gulf of California anymore. It used to flow into it, and sometimes it's a trickle, and other times it doesn't even make it, depending on the time of the year, season, all the various things. It's experienced some severe drought since 1999. We've had drought. It's not been drought ever since, but it's been drier than it has before, causing problems. And climate change is expected to further reduce the river flow. Once again, it's depending on these snowmelts, not getting as much of that, and it creates an issue. As once again, it's flowing down through this whole thing. The watersheds, we have an upper basin and a lower basin based on the colors there, but the Colorado River Basin. We'll talk about it. The Mississippi River, there's lots of river basins out there, but as a case study, we'll come back to it and visit it often. So chapter 13.1, just the Earth's water resources. What are we doing with it? What have you? It's one of the Earth's most important forms of natural capital. Without water, there's no life. It is the gift of life to the planet, if you will. Unfortunately, it's used inefficiently, it's polluted a lot, and because of its low cost, we don't really think about the cost of water when we're talking about running a tap or washing our sink. It's fairly low cost, and because of that, it tends to encourage waste. You figure, well, it's not that big of a deal if I run too much, it doesn't cost us that much. But it's something we need to be careful about. Why are we managing water poorly? I mean, if it's that important that we can't have life without it, and its gift to us is life, why do we manage it poorly? Well, it winds up being a global health issue. To try and give some aspect of it, on average, some 9,300 people die every day from a lack of access to safe drinking water. Now, let's put that in perspective. That is 25 747s falling out of the sky every day. Now, if we were to read about jumbo jets crashing every single day, 25 of them, we would be up in arms. Oh my goodness, we have to do something. We got to stop this. We can't have that many people dying every day because of plane crashes. We've got to make it safer. Well, that's what's happening. We have that many people dying every day because they don't have access to safe drinking water. We should be up in arms, but it's something that happens all the time and we become desensitized. We just go, oh, what do you do? It's an economic issue. It's vital to provide us with food and energy, two things that we have to have. To create the energy creates a lot of heat. We have to cool that down. We use water to do that for the most part. It can be a national and actually a global security issue, along as being an environmental issue. When we take out too much of it and it doesn't have time to recharge or refill or replenish, it can. So we have all of these. It's a health issue, it's an economic issue, it can be a security issue, and an environmental issue. All of these things just having to do with water. Now, most of Earth's fresh water is not available to us. We have talked about this in a previous chapter. Do you remember how much is available? 0.024% is available to us. I mean, we can actually access it and get to it. A lot of it is in deep groundwater. Now, there's groundwater we can access, aquifers we can get to, but there are some deep aquifers that we really can't access the water. It's way down below what we think of as the water table. But groundwater, lakes, rivers, and streams. Most of the fresh water on the planet is trapped in ice. We can't access it. Most of the water is obviously salt water. That is fresh is trapped in ice, or it is deep under, like 1.7% in ice, about 1.7% down deep where we can't access it, leaving us a very tiny fraction. Now, the hydrologic cycle, the water cycle, is responsible for the movement of it from the ocean up into the clouds, rain, back in, etc. There's plenty of fresh water out there for us all, but it's distributed unevenly. Canada has a very small percentage of population on the planet, 5% or less, but 20% of the fresh water resources are there. It's just not the same distribution everywhere. We have a lot on the East Coast, but not as much on the West Coast. It's this place all over the planet. And then you and I, humans, alter this cycle. When we're withdrawing, pumping water out of the aquifers, we can pump it out faster than it can recharge, then the water can drain back in. It can take a long time to refill an aquifer because it's got to sink down through the sand and the dirt, and this is a long process. But when we withdraw too much or we pollute it, and even causing climate change, more to evaporate out, it causes issues. So humans do actually affect the hydrologic water cycle, how much we can access, where it is, and is it clean, is it safe to drink? Now, when we talk about groundwater and surface water, right? Groundwater, that's when we're talking about it's down in the ground, under the soil in some shape, form, or fashion. And we talk about a zone of saturation. So it rains and it sits on the ground and it soaks down into the ground. Well, the spaces in the soil, permeability, where the water can seep down through. Spaces down below the soil, below a certain depth, get filled with water. So it seeps down, but somewhere down here, it hits bedrock. It can't go through it anymore. It seeps, it filters down, and then it hits solid rock and it can't seep into it. And then the water begins to fill up. So that's what we talk about. Below a certain depth, these areas are filled with water. That's what we call our water table. This is the top of the saturation zone. So you get a lake and the area goes down, it dips into this saturation level. That's what we talk about our water table. How deep do you have to drill a well before you reach water? We're trying to reach the water table. And then aquifers. Once again, we're drilling down, getting into an aquifer, this groundwater. Now, aquifers are recharged naturally just by precipitation, seeping down through, or nearby lakes. It'll seep sideways out through a lake down into our aquifers. So it's either happening from the rain and it's seeping down through the ground slowly, coming in by nearby streams or sometimes lakes, so it can fill from the top down or even the sideways out. Once again, it's going through the ground until it's getting to this bedrock and it's filling upwards. So we talk about our water table. Now, surface water, this is where you can walk out there and stick your toes in the water. Surface runoff, this is our lakes and streams and creeks, what have you. We refer to this as a watershed. Aquifer, groundwater, it's down under the water. Surface water, these are lakes, rivers, and this is part of our watershed. It rains and the water leaks off the top of the ground into the river basins and lakes, what have you. So we talk about this groundwater and surface water, whether it's down underneath, going into the water table, or up on the surface, where you and I can actually walk into it, run into it, play in it. The picture that we're looking up here is showing, the precipitation, it rains, we have a lake, etc., and all this contributes. We notice we have kind of a shallow aquifer, like up along with the lake, that's that water table. And then there's a permeable layer of rock, and sometimes we'll get these deep aquifers. And usually these deep aquifers are not really readily available to us. We can, and we drill down really deep to get to them, but they're pretty hard to get to, and sometimes they really are beyond what we can actually drill and get into. Now, our water use on the planet is increasing. 2/3 of surface runoff is just lost to seasonal floods. You know, because it rains really hard this time of the year and it just runs off and it's kind of gone. It doesn't have time to seep in, to get down into the aquifers. It's just really quick runoff. Now, we also have what we call reliable runoff. This is the remaining 1/3. 2/3 of it is when it rains quick or we get flooding and et cetera, and it just washes off too quickly and is gone. Reliable runoff. This is reliable source of fresh water. It's what we count on as it rains lightly and it comes in. It's what's keeping our rivers at their normal current flow. If you live here around Gainesville and you've been here during flood times, oh my goodness, the Santa Fe River is way up out of its banks and spilling out. That's what we're talking about, the 2/3. It just washes out and it's gone. But where the river normally stays, this is our reliable runoff. Now, worldwide averages for using water. We're relying on this 1/3 of what we get. Well, for irrigation and crops, 70%. And we're just talking water use. Where does it go? 70%, like our food production from the chapter before, is going to agriculture, watering the crops. Industrial use, making things, manufacturing, generating power, and generating power is a huge part of it, 20%. And only 10% is used by kind of you and I, what we think of, taking a bath, washing our car, cooking our clothes, drinking water. It's only 10%. Very small percentage of the water used is actually you and I in our houses using water. Most of it's irrigation. And we also can talk about a water footprint. We've talked about ecological footprint, you know, all the resources needed for my lifestyle. Clothes I buy, car I drive, house I live in, etc. But a water footprint is that, the volume of water that I directly and even indirectly use. We think about it like how much water I drink a day. Well, it's not just how much water I'm drinking a day. It's water I'm drinking, I'm taking a bath, I'm taking a shower, I'm flushing the toilet, I'm washing my dishes. All of that is direct use. But we also have a lot of indirect use. I buy this shirt, right? Well, it took a lot of water to make the shirt. We had to get it was probably wool, but we have to get the cotton and we have to wash the cotton off. There's water involved there. And then we dye the cotton and we rinse the dye out of the cotton. More water again. We make the fabric. The shirt gets made. Then they wash it. You get the idea. All kinds of water was used in the manufacture of the shirt. So when I go buy the shirt, indirectly, that's part of my water footprint. The picture we have back here is showing this kind of virtual water that we don't always think about. Now we do something like drinking a cup of coffee. We go, okay, yeah, you know, but there was water used in growing the coffee, right? We had to put water for the plants to grow, then we get it, then I boil my water. You know, that part of coffee I'm drinking is only part of it. And they talk about it in terms of a tub, a bathtub, somewhere around 40 gallons. And if you want to convert that into liters, it would be 40 gallons times 4. So like 160 liters, give take, it's not exact. Bread, I have a loaf of bread, costs about 4 tubs of water. Once again, we got to grow the grain, right? Grain takes water. A hamburger, 12 tubs. 12 tubs for a hamburger. The cows out there, right? We're watering the grain to feed the cow, and then the cow is having to drink water as well. Lots of water in it. T-shirt, my shirt, 17 tubs of water to make the t-shirt. Pair of jeans, 72 tubs. We gotta grow the cotton, we gotta dye the cotton, we gotta wash the cotton. Lots in the process. You get the idea. Our virtual water print can get really big, really fast. The more we shop, the more we buy, the more water is needed to manufacture all of these goods. Our freshwater resources in the United States. There's more than enough fresh water, but once again, it's unevenly distributed and some of it's even polluted. The pie charts back here, you can look at them in the book. We'll take a look at them in class. A little hard to look at, but whether it's going to irrigation or it's going to our farms, what we're using for showers, etc. So there's enough fresh water here, but it's a matter of distributing it. And it's not easy to tank water from here to there or to pipe it. So it just provides issues. Now, if we look at the map back here, it's a lot easier to kind of look at instead of the pie charts from a distance, etc. The dark blue, this is basically the annual precipitation where we get a lot of rain. So the dark blue is heavy amounts of rain, once again up from the Gulf Coast along the eastern seaboard. The water comes in. When we think about our biomes, forest, grassland, desert, we get the same sort of feel for it. So the yellow, very little rain, light green, less rain, blue, fair amount, dark blue, lots of rain. The next graphic up here is looking at areas where we're going to have problems. The red, these are areas that we're likely to have conflict over. Counties, states arguing, fighting over the amount of water that's there. More people are getting less water. Once again, that Colorado River system coming in, trying to provide water for all these areas. And this is an area that doesn't get a lot of rainfall. So we have water stress, if you will, fighting over these. And these freshwater shortages are just going to grow. More people on the planet, climate change occurring, it getting warmer. Some areas are getting less rain, some are getting more, but once again, it's unevenly distributed. What do? And we can't always just pick up and move because somebody owns that land and we own this land. Many of the world's major river systems are already currently highly stressed. The Nile, the Jordan, the Yangtze, and the Ganges, these are some of the major river systems, and they're all already highly stressed. The Ganges, oh my goodness, I'm sorry, it is so polluted. I have been to it on multiple occasions, and the amount of pollution dumped in this major river system is just horrendous. The Yangtze is, once again, is providing water to so many people that it is stressed. There's only so much more we continue to pull out of it without causing any more problems. More than 30 countries right now are facing water scarcity, not enough for the people there. By 2050, the estimate is that number is going to double. There's going to be over 60 countries that are in water scarcity. Don't have enough fresh water for the needs of the people living there. 30% of the earth in the land area right now are experiencing severe drought. The predictions are droughts are going to get worse before it gets better. As we go through different cycles, it just creates problems. When we look at the map up here, and once again, along that 30th parallel, that's where the cool, dry air is sinking. So we tend to have less through there. And this is where our desert, but boy, that whole area of northern Africa into Saudi Arabia up into, I kind of refer to it as the stands, Afghanistan, Pakistan, all of this area. Just really dry, hurting for water. And even in North America, our western states have a lot of shortages. But you can see the map, areas where we have red, definitely very high stress of water, all the way down to the gray, none. So, you know, we're in tropical rainforest, heavy amounts of rain. In the US, we still have some stress on the eastern seaboard, just because that's where most of our population is, higher population. Now, as we push in and look at this, there's a few things you may want to think of yourself. What are some of the top primary uses of water in the United States? What are we using it for? Yeah, agriculture and industry. What about in a typical U.S. household? I mean, just what are we using it for in-house? And by and large, it's kind of toilets. Every time you flush a toilet, depends on your toilet, somewhere between 2.5 and 9 gallons every time. Think about how many times you go to the bathroom, how many times everybody else. It's a lot. Flushing toilets, washing clothes. These are some of our biggest ones, talking about countrywide, power and irrigation, and you and me in the home. We got to do what we can to cut back, but that wraps it up for section 1. Next time we'll try and look at sustainability of groundwater. What can we do to keep all this stuff more sustainable? Take care, guys, and we'll see you next time.